It's a pleasure to introduce George. I've always thought of George as a Newfoundlander because he's been there so much of his life. But I said, Murdoch sent me his CV this morning, and to my surprise, I discovered he actually grew up in a fishing guiding family in Ontario and didn't go to Newfoundland till later after he got his PhD at McGill. So George is known globally for a large number of publications, a lot of them related to the spatial dynamics and survey methods used in the Newfoundland cod fishery. He's, I guess you'd call one of about three cod fathers in eastern Canada who's devoted a large proportion of his career to try and understand the decline of the cod stocks off Newfoundland and their very, very long-term history there. So he worked at DFO for many years in Newfoundland after getting his PhD, and then got an industrial research chair, industrial research chair at Memorial. Managed to get out of the DFO mess into university, and then has just retired about 2015. I guess he retired, and he's now an honorary professor in our institute, and we are most lucky to have him, and we're most lucky to have him today. Take it away, George.
Thanks very much, Murdoch and Carl. One correction though, Carl, I am a Newfoundlander.
Wonderful.
Born in Newfoundland. Actually, I'm one of the original Newfoundlanders because born prior to Confederation with Canada, and lived my early life there on the fishing wharfs. I did become a fishing outfitter in Ontario, but that was somewhat later in life.
So, I thought I had that right. Yeah.
Well, you were real close. But you can't take the Newfoundlander out of me. That won't happen.
Absolutely.
Anyway, it's nice to be able to talk to you this morning, and I hope the connections are all right. You can hear this. I do want to talk again about northern cod, and particularly in this morning, talk about particular aspects of it that have kind of bothered me for, well, decades, really, for a long time, and that is the stock structure of the fishery. And I don't know if you can see my little icon here, my little mouse, but right from the top of Labrador all the way down to the middle Grand Banks, this was the distribution of what used to be called.
Oh, hang on, George.
Yeah.
Right click on your screen and or hold your right mouse button down, and there'll be a pointer option.
Oh yeah, I see it. Yeah.
Okay, go to that and take the whatever it is. There should be one for laser pointer. That's it. Yeah. Then you there you got a pointer. Okay.
Excellent, Carl. Thank you. Anyway, yes, from the northern tip of Labrador all the way down to the middle of the Grand Bank. Now, this was traditionally thought to be the range of the northern cod. Now, all of that has changed, and I'm going to go into this in some detail. But the northern cod now is just considered to be from about here, which is NAFO 2J, down to 3L, which stops around here in the middle of the Grand Bank. And what I want to really talk about is how this has been sort of developed over time since we have data on this stock, and the spawning stock recruitment distributions that have come from this. This has been looked at for a long time, and then sort of end up talking about reference points and management, which is current. I said earlier that this had bothered me for a long time, and it kind of came to the fore when Carl and I published this paper in 2019, basically challenging some of the outputs of the DFO assessment using their northern cod assessment model, or NCAM. But we concentrated on differences that came from the two different models in the mortality rates, basically. And I'm not going to go into much detail about that today, but it has a bearing. But I got thinking about that. And then more recently, when DFO came out with their rebuilding plan for the northern cod, which was based on spawning stock biomass recruit data, then I really started to think about it seriously and how this, and that's what I kind of want to talk about today. It's a work in progress, but I want to kind of talk about this as we're going on. Now, before we get into it, I feel I've got to go into a little bit about the ecological background of this area, the very brief about the fishery, the stock structure, what's the northern cod, spawning distributions and how they may have changed over time, and then the dependence of this spawning stock biomass recruitment data on distribution and what may have caused some of the changes. And by then I would like to present some things that compare the VPA that Carl and I did with NCAM, the DFO current assessment model. And then of importance, I think, why any of this matters, especially to management of the fishery, which is the critical thing right now. So just very, very quickly, one of the chief properties of this whole ecosystem, right from the north point of Labrador all the way down, is the Labrador Current. Now, this is a very strong Arctic current. It's very cold, and it really dominates the whole system. There are all kinds of back eddies, so there are ways in which, you know, things can get both passively and actively back into the coast. This happens, and we've documented this through migration tracking and tagging and so on for a long time. But it's really important to realize that this is kind of a conveyor belt, especially when we're talking about spawning, where spawning occurs, and what's going to happen to the eggs and larvae. And this little bit up here kind of shows a cross section of, it's not all the same all the way down, of course, but basically what we have is this Labrador Current of very cold water down to -2. I mean, it's unbelievably cold. Really very little can live in that water, and the cod don't live in it. They go through it, but they don't live in it, and they certainly don't spawn in it. They tend to spawn in Atlantic Ocean water, which kind of underlies on the shelf down usually around 300 to 400 meters in total depth. And one of the things that can happen over time, and does happen, is this Labrador Current varies in its strength and also in how dominant it is. And in some years, and this can go on for a number of years because there tends to be strong autocorrelation in this, it can get very, very deep. And in fact, to the north, it can almost force fish out of the area to a large extent, in the sense that the habitat for them, which is usually 2 to 4 degrees where they like to spawn, is reduced considerably. Other times, not so much. So this kind of shows that. Very important thing. Now, there have been very few studies done of where these cod actually spawned and what the result of it was in terms of egg and larval drift over the years. Now, one was done actually by John Anderson and myself in the early 90s. And we were looking at, okay, this represents, the blue dots, the blue bars simply represent the relative abundance of the spawning fish in this southern area around Hamilton Bank Hawk Channel, which I studied for a number of years. And it went from 94, 95. So we had some good range of spawning abundance during these years. And, you know, John did all the work on the pelagic juveniles, and we found a very, very strong hookup. So, you know, this is just an example to show you how that system works. Spawning usually occurs in the northern areas, drift comes to the south, and, you know, this is where the juveniles will grow up. And it really does depend on how much spawning biomass is there. So that's a very, very brief summary of this ecosystem as it pertains to cod. Now, what about the fishery? Well, this is an old fishery. We have records going back to the 1500s, and this is a reconstruction that I did a number of years ago. But in the 1500s, all the way up to about 1800, most of this fishery was seasonal and migratory. And you can see the catches were relatively lower. These are actually landings, and they're based on export data. So they're probably underestimates estimates of what was actually caught, but they are, relatively probably pretty comparable. And this fishery went on for hundreds of years, and it was seasonal only in the summertime, mostly by the countries of England and France. They were dominant, not the only ones, but dominant. That all changed in the 1800s, and you can see the change here. We had much higher catches in the 1800s, and right up, basically, this is the Second World War, so there was a decline, but basically right up until the early 1960s, we had increasing catches, and they were in the range of 200 to 400,000 tons a year. So say on an average, during this whole long period of about 150 years, the stock produced about 300,000 tons. Now, it's curious about this because this fishery here was almost entirely on the northeast coast of Newfoundland. It is around the island in the southern areas. This fishery expanded considerably to the north, and I was very interested in, okay, where did these fish come from? Where were they caught? And as it turns out, probably the majority of these fish actually came from off Labrador, not off the northeast coast of Newfoundland. And you can go back in history, and there are many. I'm quite a history buff, especially about these fisheries. But if you go back, there are many anecdotes. I just pulled a few out here just to kind of make the point. Captain John Davis, this is in 1586, very early on. He found a great abundance of cod, largest and best fed fish that ever I saw, right up to almost 55 degrees north, which is, middle Labrador. And actually, Captain Davis was so taken by the amount of fish he caught. He was an explorer, not a fisherman. He came back the next year with his fishing crew to fish in order to fund his research, basically his exploration and research. And of course, Davis Strait is named after him. And then in this, to carry it forward in time, in the 1700s, New England fisheries, all the way down from New England, came all the way to Labrador. They bypassed the Grand Bank. They thought fishing on Labrador was far more enjoyable than in the fog on the Grand Bank, or even off the Nova Scotia banks. And they were all the way up to 56 latitude, which is 2H, which is, remember, not part of what is called northern cod now. And this was occupied from June to the end of September, so a seasonal fishery. And then to bring it up in time, when Newfoundland started to become heavily settled in the 1800s, 700, this is from one report, 700 Newfoundland schooners on the Labrador coast. They were all the way up. By 1908, 1,400 Newfoundland vessels were involved in the Labrador fishery. And many people, fishermen from fishing families on the northeast coast of Newfoundland, went actually to Labrador to fish. They didn't fish in their own grounds at all. They went to Labrador because that's where the fish were. And Art May, who did his PhD thesis on this fishery in the 1960s, I think it was the first one ever done, the first thesis ever done, estimated catches of these vessels to be at 300,000 tons annually a year. Yeah, that's the bulk of it. So this is the basic fishery, was a Labrador fishery from about 1800s all the way. And then we know what happened in the in the 1960s, if you're familiar with that. I'm not going to go into it, but that's when the stock was decimated by foreign-based trawlers. And during that time, it was largely off Labrador as well. So that's where fish were caught, but where were they spawned? What was their production source? This is the thing that's bugged me for a long time. And, you know, we know pretty well where they were caught, but where did they come from? Well, fortunately enough, way back in the 1960s, with the increase in interest from basically the former Soviet Union, Eastern Bloc countries, and also Western European countries in fishing off North America, and particularly off Newfoundland and Labrador, a tremendous amount of research was done in the 1960s. It was started by the Russians and continued on by people from Denmark and Iceland and France, and a little bit by Canada, but not much. And the interesting thing, there are various sources of this, and the literature is quite extensive, but I've just tried to summarize it here. In the stage 1 cod eggs from the 1960s, and this was a 62, 63, 64 is when most of this work was done. The blue of the pie represents stage 1 eggs, and then the other colors are stage 2, 3, and 4 eggs. But you can see that the bulk of the stage 1 eggs that were done in these massive ichthyoplankton surveys, and they were massive. This is basically the largest ichthyoplankton work that's ever been done in this area of the ocean. The bulk of them came all the way up from Saglek Bank, which is this bank off northern Labrador, and then furthermore down. But once you get down to 2J, which is where the northern cod is considered to stop now, basically the eggs, these are stage 4 eggs, which means that they've drifted for quite a while before they got there. So all the indication is, and this is not news in the sense that most all of the active scientists from Newfoundland and from the foreign countries that were involved in research here, all at the time concluded that these areas up here were where most of the cod reproduction was taking place. And this, in Sarah Bryakov, a Russian scientist who summarized and did a lot of this work, this is where this dark kind of salmon color, this is where he thought most of the spawning took place, with lesser amounts of spawning taking place further south in these areas now, which are considered to be the range of the northern cod. So that's kind of what the situation was up until the big decline in the stock. Now, this data is, this is reported catch from 2J, and this is 2J, and then further north in 2H and 2G. This data shows that most of the catch was reported to come from 2J, which is southern Labrador, during this time. But one of the problems with this is that it's so dependent on fishing effort, and because what is expected and what the Russian tagging work in the 60s showed is that the fish that were tagged in further north migrated after spawning very quickly south into 2J. So this data has always been used to highlight the importance of 2J. And while I'm not discounting that, I think that, that there are other explanations for why this might be true, and that basically where the fish were caught may not be exactly where they've spawned. I just put these echograms up here because this shows you what pre-spawning, and this is actually post-spawning, and these two are pre-spawning, and this is kind of in the middle, what they look like and why this fishery was so vulnerable to the trawler fishery, that bottom trawl fishery that really started in the 1960s. So what happened after that? Well, I wanted to mention this too, that this is another explanation of why that fishery could have been so dominant in 2J, even though the fish were not spawning there. This is data that from the early 90s, when we know the range was contracting to the south. And what happened was that we saw this rapid range contraction. And did the catch per unit effort from the trawler fleet go down to catch? No, in fact, if they either remained as high as they ever were or even went up. And we called this hyperaggregation. That is, when the stock was in a decline, it was moving to a certain area, in this case to the south, and was actually really hammered hard by the fishery. And I wondered if the same thing, even though we can't, this is only speculation, we can't prove this, the same thing happened in the late 1960s around the off Labrador, that we had this massive concentration, which allowed that 800,000 tons to be taken off southern Labrador. Okay, so the next question then is whether the stock unit, that is the production unit, what I would consider the production unit, is really 2J3KL, or is it really 2GHJ3KL, or it's really all of 2 and 3KL. Now, Templeman, as late as 1962, he had summarized a lot of the early, well, actually it's later than that, that's an early quotation. He was convinced that it was the whole stock, 2GHJ3KL, and the importance of northern spawning. And that kind of was in line with what most scientists at the time thought. But by the late 1970s, what with the overfishing and the changes, possible changes in distribution, 2GH was barren. No one, the fishery was gone. No one could find fish there. And so basically, the stock unit was just changed to 2J3KL. And to all effects, 2GH was just written off. You know, now, but the hook here is that the data from 2GH, the spawning stock biomass and recruitment from the 1960s was often not, and still isn't, including by myself and other workers, is not written off. And the disparity between those two approaches needs some clarity, and that's what I want to talk about. Now, here's what happened after that. So we saw that early map of spawning distributions, and here are 4 more attempts that have been done. This is actually from another Russian work by Gerasimov and Kiseleva, 1995. So this is a late summary of where the northern cod spawns. Now, this is an original reproduction from Sarah Bryakov's work in 1968. But if you notice, it's cut off here at 2J. That is all what I showed before up this way is just considered written off. It's gone. And same with Fitzpatrick and Miller. That was a Canadian work that was really not based on anything original, but just a resummary of some of the earlier work done internationally. Was also cut off, even though that had gone up a little bit higher as well. And Hutchings' work was done in 1993. Now, some of these are based basically on ichthyoplankton surveys and also on tagging and capture of spawning fish. This is based on another interpretation from Canadian surveys of mature fish. And you see a pattern that's very different, but again, even in 2J, showing basically nothing. And then Gerasimov and Kiseleva re-summarized their work, and this is what they thought. But well, without going into any detail on this, the key point is that after about the 1970s, 2GH was just totally written off. So that brings us to the point of spawning stock biomass recruitment, and this is the basis for reference points in management of this fishery. Now, for the northern cod, it's always been thought, this is an old thought, has the most linear spawning stock biomass recruitment relationship of all the cod stocks. In other words, very little density dependence. And this has been repeated basically as recently as well last year by DFO. Everyone pretty well is on side with that. And it's, they basically, this is a quote from their report on their reference points, that the relationship appears to be linear over the time period that they have, which they have back to the 1962. Now, this is more normal for cod stocks. I brought up two here just to make this point. This is from the Northeast Arctic cod of Norway and Russia. This is from some earlier work, but I've updated them down here. And we don't need to spend too much time on this other to realize that there's no kind of linear trend in these, and you can draw many different models, and they've all been drawn through this, or non-models or whatever. But this is kind of typical data for cod stocks, other than the northern cod. And one of the things that occurred to me that could be causing this difference is that when you have an increase in the spawning stock biomass, it's kind of an assumption, even though it's an inference, it's not really stated assumption, that the area remains kind of the same. In other words, density goes up. But what happens if that doesn't happen? What happens if what really happens is when abundance goes up, as it may have in Labrador, if you consider northern extension, that the density really doesn't go up at all. It's just that the abundance goes up. And that I think is a possibility of the cause of the linear data that we see for the northern cod. Now, the rest of this, or part of this, is going to either be drawn from work that Carl and I did, or I've kind of updated it and so on, but from this, and also from in comparison with the NCAM model. As I mentioned earlier, Carl and I concentrated in this paper on differences in the mortality rates and how that was impacting the biomass, and also the perception of what had happened with this stock. But we didn't focus too much on stock on recruitment. But this is data then drawn from that model, and you can see it's pretty linear, all the way up. But one thing that I want to stress with these data is, you see all these points. I put the years on here, and these are all the data. These are data from the 60s. These are data from these are the exact years when that early ichthyoplankton and spawning work was done. And you can see that it's categorically different than what has followed. And so this kind of, in some ways, represents, if we believe the earlier data and don't discount it, this represents spawning off northern Labrador. This represents when there was no spawning off northern Labrador. And that was 2-year-olds, and this is 3-year-olds. Doesn't make any difference, because this is from a VPA where basically there's no fishing on these younger ones to speak of. So it's just natural mortality bringing the line down. But again, so the reason I've shown these both is because in comparisons with other work, sometimes people have used 2, sometimes they use 3. So it really doesn't make any difference as long as we compare the same ages. Now, another way to look at this is just to look at time series. So I've looked at the time series of the stock, and the stock is the blue, and the recruitment at age 2 is in the dotted black line. And I applied some time series analysis this with these Perron breaks, which basically are unexpected changes. That's the way they are described in the literature, unexpected changes in a time series. And it's no accident that these line up almost exactly with what we've been talking about, with the late 60s, a big change, and another change here in the with the collapse in the late 80s and early 90s, and then perhaps another small one with the tentative rebuilding that's taken place over the last decade or so. So basically, if we want to look at this as where we think the production came from, this is northern Labrador. This is two, so this would include all of 2 up to northern Labrador. This would just be 2J3KL, the current status of the stock, and this would be the kind of depressed state of the stock after the collapse in the early 90s. So that matches up pretty well. And if we look then at trying to draw some lines or models through this, now this is a Beverton Holt at age 2. It's done with log normal error from 62 to 2015. And, you know, if you wanted to kind of speculate on a reference point for this, it'd be around 1 million tons, or maybe slightly less, but, you know, somewhere in that area. But even so, when you look at that, all of these points from the 1960s are above the line. And that's not the case for any of the rest of it, where you see a kind of a random distribution of points. But there's something different about the 1960s recruitment, even if you try to model it in terms of spawning stock biomass. And I just put this on that was a log scale, but this is on the arithmetic scale, because it just highlights the differences, but you can see these points. Now, if you just take the residuals from that model, it actually kind of interested in this. Okay, why would it be even greater? We've kind of thought from drift theory that northern spawning was better because you're drifting in very cold water. The development time of the eggs and larvae is long, up to 2 months. So, you know, it's kind of like the quicker you get on that conveyor belt, the better chance you're going to have for survival. And it does kind of look like this, that, you know, you get positive residuals during certain times and then negative during these times. And it lines up pretty well with the Newfoundland Climate Index. Now, it's not perfect by any stretch, but there is some relationship here between the decline that occurred here and then an increase in the 1980s, and then up to 1980, and then in the 1980s another decline at around 1990, which we know was a very cold period. And then it's hard to really see any relationship beyond that, but that's probably because the stock was so low. So there is some evidence here that, you know, that it could be there could be a climate factor influencing where those fish were spawning as well. And the input that further north, when the good years, when they could spawn further north, they would get stronger recruitment even than the spawning biomass would predict. Okay. So now to the really important part. Why does any of this matter? It's kind of the reference point rebuilding management ideas, because in most cases, these points that are coming out are based on this spawning stock biomass recruitment relationship. Now, just for fun here, what I've done is ignored in this analysis. I've just ignored all these points and said, okay, those aren't in the stock anymore, because and by what we're calling northern cod now, 2J3KL, they're not. If we believe the early ichthyoplankton and spawning surveys, that these did not come from 2J3KL. And what you get is from the VPA that we did is a cluster of points down here. And I put 3 models in. Two are Rickers, one with normal error, one with log normal error, and then a Beverton Holt, which is the black one with log normal error. They're not all that different, but what they indicate is that, you know, if you wanted to look at a reference point, it would be in somewhere in this area, 500,000 or tons or something like that, which, as we'll see, is considerably lower than what DFO sets for reasons that are not entirely understood. And this is the problem that we have with the 2 different versions of the stock. And I put a couple of things on here. The green is this is representative of historical DFO assessments. Now, I think the last VPA that was done and accepted was done in 1993. There were attempts to do things after that, but this represents, the green line basically represents up until 2000, and this was redone by Anderson and Gregory. But and there are some differences over time, but you know, basically this is what was thought to have happened. And the Rosen-Walters model is very similar to that. It has some small differences, but basically the patterns are very, very similar. DFO NCAM, however, this is age 3 recruitment, very different. And what we have here is a incredibly high indications of recruitment during these years. And why that's the case, I'm not positive, because the NCAM model is rather an opaque beast, and DFO does not give out much information on it. And even now, they're not even putting out on their on the website, on the CSIS website, the res docs, which were always the source of the basic information about this stock. They don't put that out anymore. They just put out summaries of the model. So it's really hard to know how these how this was determined. But if you look at the what we criticized about this model, about you know, the emphasis on huge amounts of natural mortality in the early 90s in this area, it may be that because they're putting this huge natural mortality in there, that they basically have to create huge amounts of recruitment to satisfy the model. Basically, huge amounts of young fish that they can kill off. I don't know. I'm really not sure about that, because we just can't do it. But the point is that even though the trends are similar, the absolute amounts here are just light years apart. And that model, then, the DFO model, is the basis of their. They have just released a report on their rebuilding plan, and it's based on basically on these data. And what you see is this very odd stock recruitment relationship where you have an almost beanstalk of stock sizes around 800, 900,000 tons. This all comes from the 1980s. They only go back to 1983. And then virtually very little, with nothing in between. It's quite an odd thing. And their reference point of 880,000 tons is basically just the average of these points. So it's not based on a model or whatever. And I know in the paper, we kind of said, well, you know, what we determined was very similar to what DFO had determined, but it's a coincidence, I think. It's not based on the same thing at all. And if you look at that, this is an NCAM model, which, to be fair, DFO has not accepted and says there are problems with it. Basically, it doesn't fit the data. And they don't give in their report. Again, there's no published report on this. This is just a repeat of a graph that they put in their reference point document, which is listed here. These points here, they'd almost certainly be those same points from the 1960s, and they are including them. And this is the reference, which really doesn't make any sense in terms of the data. So they're trying to do it both ways. They're including data that probably don't come from 2J3KL, and then only using the reference point from some point here, which these points are questionable from the 1980s. Another thing I wanted to point out from this about NCAM, I'm quite curious about this, is that if we look at the spawning stock proportion of the total biomass over time, now this is from the VPA. It's usually, it bounces around quite a bit, but it usually, and certainly back in the 60s, if we want to look at that, it was around 50%. So this would indicate if the spawning stock biomass was near 3,000 tons, or sorry, 3 million tons. Yeah, this is by 1,000, of course. You would estimate that the total biomass was about 6 million tons, which I find hard to believe. And certainly it like a lot of the other things that NCAM has put out, it kind of rewrites history, because in all of the work that's been done in the past, that's just too high. There were never that many fish in this stock. That would put it above any cod stock that's ever existed on the planet, including that off the Northeast Arctic and so on. So I got a lot of questions about this one. And if we just compare it, the green dots are from the VPA, and the blue dots here are from the extended NCAM. You can see the difference between the two. So with these points are basically marching down from the 60s in terms of spawning stock biomass and their effect on recruitment, whereas we're not sure. But again, this extended model of NCAM is under discussion, so I don't want to criticize it too harshly, other than to point out a few things that to me don't seem quite right. So, you know, in just looking at the data from 1983 to 2013, these are H2s. We get a very different look from the VPA and from the NCAD. The blue represents, this is this stock sizes, but very, very different recruitments. And the green dots represent from the VPA, which are quite a bit lower. There's really a vast difference between these, which is puzzling at best. But the one thing that we need to keep in mind is that the evidence from the 1960s is not included here, so that you don't, the only way that it's these high levels of recruitment and biomass in the 1980s that are driving the reference point that DFO has determined, and not from the 1960s. So this is now from the rebuilding plan. This has got a lot of attention recently. How it's a rather complicated way. The building plan has been criticized by a number of organizations and so on for a number of reasons, and I don't want to go into that in any great detail, but it's fairly complicated in this, and it might have been better just to set a catch level. It could have been a fishing mortality rate level or a catch level. I think my own prejudice would have been towards a catch level, because we're uncertain about if we put it at a fishing rate, it assumes we know exactly what the biomass is, and because there's some uncertainty about that, a relatively low but consistent harvest rate without might have been better. So conclusions. Well, if you look at the whole series right back to 1962, which is the preferable thing to do, the longer the series, usually the more information. It really shows no density dependence at all, which is puzzling if you think about a stock that's in a certain area, and because most other cod stocks show density dependence if they're in with a certain area. So it suggests to me that it's the area expansion which has caused that. And if you look at the spawning stock recruitment of just 2J3KL, where we think that spawning production was coming from this kind of late 70s on, there is density dependence shown in the VPA, but not by NCAM. And so that's kind of a curious point. And but the one criticism I would have now is that the reference points that are used right now don't recognize this stock unit issue. It's highly questionable. I think it needs to be addressed. And DFO needs to make a clear statement of what the goals of rebuilding are. Is it to rebuild 2J3KL or the full 2GHJ3KL, and in either case, they must make it clear where it's likely those data were coming from. The only other answer to that is just that that early research that was done is just dismissed as being incorrect or wrong, which, after looking at it in great detail, I find that hard to believe, because that research was quite extensive and quite carefully done. And basically to match up what these production area and stock areas are, and the consequences of that to the fishery are extreme. So I'll leave it at that.
Thank you very much, George, for an excellent and really interesting talk. I've got questions, but I'll open it up first of all to other people to ask their questions.
George, could I jump in right away? It sounded to me like you were saying that 2.5, 3 million tons as a biomass for the entire complex, including 2GH, would be unreasonable. I don't think that's right. I don't think
For a
2 million
spawning
tons
stock,
is at all inconsistent with the, as an unfished stock size, is not at all inconsistent with the long-term catch data and so on that you've analyzed back into the 1500s. Or did I mishear you there? Because
no, you didn't mishear me, but you might, yeah, that catch data that back to the 1500s, that is for all of the Newfoundland stocks. And in that reconstruction that I did in 2004, if just off the top of my head, I think I came to about 6 million tons in all around Newfoundland. That'd be the northern,
right,
the Grand Banks, southern,
yeah,
the 2J or 3PS, southern Newfoundland, and also the Gulf. So 6 to 7 million tons. So, based on now this is all a little bit of conjecture, but based on 3 million tons of spawning biomass in the northern cod, if that was half, that'd put 6 million tons of biomass in the northern cod alone, which just seems to be a little bit high. I could believe, based on what we've seen in the past, 3 to 4 million tons as a but I find 6 is just too high with everything that's been looked at in the past.
hmm. Yeah, because when I did our stock recruitment analysis on our VPA runs and so on, I came up with a unfished biomass, vulnerable biomass on order of 3 million tons, and a lower spawning stock biomass quite a bit,
Yeah,
2 million tons. Well, a big distinction between the biomass that's harvested and the spawning stock reference biomass. But I was more worried that DFO, in analyzing the shorter time series that does show some apparent density dependence, that they were going to conclude that the reference point should be set lower than they should if you consider that they should be trying to rebuild the entire 2GH 3KL complex, not just the 2J 3KL part.
yeah, then that's a good point, and that's quite possible. I just think there's a lot of confusion about this because everyone now, including myself, I'm not separating myself from this criticism, has referred to it as 2J3KL, and that's been it. But I think that there's good evidence that the historic stock was actually 2GHJ3KL, and all those high points that we've used them, and DFOs, why wouldn't you? You should look at them. It's very likely that really needs to be considered as the full stock in order to consider those data points. But I don't see anything like there's nothing about this in the rebuilding plan that DFO has put out, which is something that I think is causing some confusion.
There's a question by Professor Ray Hilborn.
Hey, George, thanks. That was really interesting. But it seems like what you're arguing is that in order to really rebuild this stock, the 2GH section has to be rebuilt, and that what happened is it was essentially wiped out by the foreign fleets. Is that is that more or less consistent with your thinking? And B, what could be done to essentially try to rebuild the 2GH section, or is it has the environment changed enough that may not be feasible?
Well, yes, I think in response to the first question, yeah, I think that's probably exactly what happened. You know, I think there's an environmental component to that as well, because it's likely that, you know, the fish congregated, but that huge spike that everybody's familiar with in 1968, well, it was around the late 60s, but 68 was the high point. Yeah, there's no question that was caused by the foreign fishing. Whether I do think that, you know, if we're going to talk about rebuilding northern cod to the level that it was back then, and I think, you know, that's a question for management and the people. Of course, my own view is, yes, I would like to see that happen, but that's only my own view. You really need to consider that whole complex right up to Sag Lake Bank up in northern Labrador. Now, whether it's possible, whether that will happen is really an outstanding question right now. The environment has changed. We know, and everybody seems to recognize that the importance of capelin to this stock, and the capelin stock is still. I just actually saw the release from the capelin stock assessment, which was just done last week, and there's no bright light on that horizon either, and that's a big problem for rebuilding the stock because it's their key food supply. So whether that stock can, you know, recolonize, I did a paper a couple of years ago arguing, based on the spring surveys that I'd done for many years, that the resurgence of cod to southern Labrador was a retaking of the environment. It was expansion. It wasn't just local production. And I think, you know, that should hold. So the stock may be capable of doing that, but, you know, I think if you look at the relationship between stock size and recruitment, it really depends a lot on having a bigger stock. So the stock has got to grow, then expand. I guess, you know, thinking of it in a sequence of events, the biomass, the spawning stock biomass grows, and it will expand that and retake some of the former grounds. But it doesn't look very promising right at the moment that will happen anytime soon.
Aaron Adamek has a question.
Hi, George. It was a very interesting talk. I was wondering, with some of Eric Patterson's work showing that there was a regime shift in the late 80s and early 90s, and then the recent stuff with the capelin stock going low or going down, and then looking at recent cod assessments where cannibalism's increasing, I'm just wondering where's the scope for growth for the cod population? Like, where's the food going to come from to support these guys?
I can't really hear the question very well.
Right.
Repeat.
Maybe it's easier if I type it in the chat.
Pardon?
It may be easier if I type it in the chat.
Yeah, I don't know if I'm going to see that.
So George, I think the question, I don't know if you can hear me, Murdoch, here, is
yes, I can hear you.
yeah, okay. Where's the scope for regrowth? You know, it just seems like there hasn't been much rebuilding with light fishing, and capelin is really you know, depleted, not coming back. So the question was, where is the scope for the regrowth? If, you know, if conditions are really bad, you know, are we actually just going to see more of the same productivity?
Well, yeah, that's a good question, but I mean, there is reason for optimism. I mean, the stock was much lower 10 years ago than it is now. I mean, there has been considerable growth. In fact, you know, a lot of people wrote it off entirely. I never held that view, but a lot of people wrote it off entirely when it was at its rock bottom in the kind of mid to late 90s. But, slowly but surely, and then, gaining ground, so to speak, over the years, particularly after about 2008, it grew considerably. And,
George, could I interject here? One of our findings was it's not growing slowly. It's
Pardon?
growing at near its intrinsic growth rate that
Yeah.
George calculated from the longer term data. It's
Yeah.
just at a very low absolute level.
Yes, yeah, that's exactly right. It has grown considerably. Now the only negative about that is that it has stalled recently, according to the assessments. But that may only be temporary. And the capelin situation is a bit of a puzzle. Unfortunately, we don't have a full survey of capelin, but the information that's available, capelin has been down for a long time, and it did show some considerable increases a number of years ago, but that seems to have stalled as well. So, but I think overall, I mean, there has been considerable regrowth of this stock after the massive declines that occurred in the early 90s. And I think that I still remain, optimistic that that growth can go, even though there are going to be stalls. I mean, I think that's should be expected. It's not a straight line. There are no straight lines in nature, and you're going to get stalls. But overall, on average, it has been growing, and with if the environment holds, all the, people talk about climate change and the influence. And I think if you're familiar with the Northeast Arctic cod, I mean, it's been going gangbusters and influenced by range expansion. Good global warming apparently has helped that stock considerably to expand to the north, and the abundance has been very high, and so on. That should happen, maybe to a lesser extent, should happen as well with the northern cod. And it has to some extent. We've seen an expansion to the north, but it's nowhere near the extent that it was historically. But I mean, it may just take time.
I see that Dwyer has some comments or questions. Dwyer, did you want to ask a question or make a comment?
Oh, sure. Thanks, George, for the talk. This is Karen from Newfoundland.
Oh, hi, Karen. How are
Hi
you doing?
there. I'm good.
Good.
I just wanted to point out to everybody that the LRP that we currently use came out long before NCAM did. And it's based on stock recruit scatter, just visually, where there's a space in the scatter. And it's the period where there's last moderate recruitment, which is the average of the 80s. And that's true no matter which model we use. And I agree with you in many respects here. But just to discuss extend cam a little bit, it's just the same model with a longer time series. However, we are putting work into that because we recognize that there is much more data that we can be looking at for this stock. You know this, obviously. And we're going to try that. We're going to do that again this year. We were derailed a little bit last year with the COVID situation. But, there are things going on. So it's a work in progress.
Yeah, thanks for that, Karen. Yeah, I understand that, and that was pretty clear in the document that was put it out, that it is a work in progress. I think it's just interesting. My main point is this stock unit question. That I think we've got to think long and hard about that, and about if we want to. We're talking about rebuilding. It's kind of rebuilding to what? Is it just, what it was in the 80s, or are we trying to rebuild to what it was historically. And if depending on the answer to that question from management, it really, we have to look at that whole stock unit issue, because people were totally convinced, and it looks like from the data that those high levels of recruitment and stock size from the 60s were likely, if not driven entirely, were substantially contributed to from Northern Labrador.
Thanks. I had a question on some technical aspects. I understood that there were a number of tagging studies, and there's still ongoing trawl survey. So you'd mentioned that there's a lot of uncertainty in the current estimates of abundance, but if there are the tagging studies and trawl surveys, why can't those data be analyzed so as to come up with estimates of harvest rates and abundance, for example?
Yeah, well,
They have been. They are used at least indirectly in NCAM, and in the sense that the NCAM natural mortality rate estimates are generally higher than George and I got directly, and that's why the NCAM abundances are higher, and part of the reason for that is using the tagging data. But it's controversial whether the tagging data have overestimated M. There's a bunch of reasons to expect that they may have.
All right. The other question was on the reliability of the catch at age data. I guess after Canada's EEZ came into play, I guess the data became more reliable. But prior to that, how reliable are those earlier catch at age data? There are survey catch at age data, so you can test for, let's say, consistency between those types of catch at age data. So the VPA really relies heavily on the reliability of those data. So have they been collected such that there's verification of their earlier reliability, or is that still open to question?
well, I guess it's always open to question, and going back in time, but I think they're reliable enough to use. I mean, the surveys that are done by the Canadian government, they didn't start till later. They don't go back to the 60s. This is data that was collected through ITNAF, basically, the International Commission for the North Atlantic Fisheries. And they're considered. They're certainly. I don't think you can dismiss them as being, although they're certainly you can consider some error in them, as in all fisheries data. But I think they're reliable enough to be used.
The 62 to about 72, something like that, it isn't actually year by year data. It's an average from sampling over that period, where I don't think there's enough fish aged in any one year to give them a reliable. So everybody's kind of used this average composition when doing VPAs or other methods on the early part of the data. But like George says, it ain't going to make that big a difference.
Yeah, so the biggest difference between the NCAM and VPA is in the estimation of natural mortality, and that's why the abundance estimates are so much different. I guess the NCAM also has to make assumptions about vulnerability at age, and are they consistent with the VPA estimates, or are quite different for earlier years?
Yeah, they're very similar.
Okay, so it's just the M that's driving the big differences.
Primarily,
then. Yeah. Okay, thanks. All right, so are there some additional questions? Okay, if not, then thank you very much, George. Thanks again for giving such an interesting, excellent talk. Thanks everybody for participating. Thanks for your questions and discussion. yeah, this is a really interesting topic, and look forward to hearing more from George as he proceeds with his further investigations. So thanks again.
Oh, you're very welcome.